First of all, we look on the structure of a proof. A proof is decomposed into fragments. These fragments consist of three parts. Now we look on three types of fragments. The first fragment is the mathematical equivalence. The second one is the mathematical equation. And the third one is a non-mathematical step. It's a medical treatment decision. All fragments consist of three components. The first component is the connection, the second one is the proof step description, the third one is the justification. If we look on the equivalence, there are two algebraic equations. The equations are equivalent, so the connection is the equivalence between them, and we have a justification, which is the distributive law which was applied from one equation to the other. The second is the mathematical equation itself. It has a proof step, which is an algebraic term, and the second proof step is also an algebraic term, and in between there is an equation. Also an inequation could be used as a connection between algebraic terms. And we have a justification, which is in this case the binomial theorem. In the non-mathematical fragment we have a treatment decision. We have a diagnosis of a patient. We derive from the diagnosis a treatment decision Y, and we have a justification for that, which is scientific results of X or laboratory results of the patient. If we want to integrate this structure into a web-based learning environment, we have to decompose a proof into proof fragments and the fragment itself into the three components: connection, proof step description, and justification. A sequence of these proof steps should be automatically assessed with individualized response to missing justification, wrong connection between the proof step descriptions, and so on. Now we leave the medical application of an argumentation or justification and focus mainly on mathematical application of an eProof environment. Now we look on the implementation of an eProof environment in iMathAS. This is the interface of an assessment with 9 questions. First of all, we look on the general structure of a proof. A proof in an eProof environment is decomposed in fragments, transferred to the iMathAS environment. The whole proof is the full assessment, and the full assessment consists in this case of 9 questions, and the questions are the fragments of the proof. The students can use all of these optional fragments for proving the theorem, or they can use part of them. When we look into more detail, the question or the fragment of a proof consists of a description of the proof step, the connection to previous proof steps, for example an implication, an equivalence, equation, inequations, or subsets, and finally the justification of the proof step, which explains the reason why the proof step is valid. Now we look into the workflow of the students. They start with logging in the iMathAS environment, and then they select a certain assessment. This assessment shows the theorem on the top of the page. This is the very beginning of a proof, and so the students have to select the start of the proof. The proof steps classify the type of proof. This assessment is designed for proving that a countable intersection of linear subspaces is again a linear subspace. The proof type is a direct proof by application of the linear subspace criterion. This fragment of the proof is a classification of the proof type. We don't need any justification of this proof step, so we enter a dash for no preconditions necessary. As the final step, we submit this selection to the eProof environment for assessment. After finalizing this step, we go to the next question and enter the next proof step. The next question again shows the theorem what we have to prove. The next line tells the student that he needs at least 9 proof steps to show the theorem. Then you see the previous proof steps, which is just the selection of the type of the proof. Then we select again the next description of the proof step. And as you might see, there are different colorization of the proof step. The red proof step descriptions are impossible. The green one are available at this stage of the proof. And there are the black ones where the students have the option to select them and check them, but they are not applicable at this stage of the proof. Only options that are possible to conclude with the given preconditions are marked in green with the current settings. When students are exposed to this eProof environment for the first time, the environment is tweaked in a way that they get a maximum kind of support, so that they feel comfortable how the argumentation of the proof is performed within an iMathAS. The main purpose of this settings is to reduce the number of options according to the prerequisites of the students. More options means more capable of selecting appropriate proof steps step by step. The settings can include the option that the students see step-by-step assessment of each proof step. So in this case, one option is missing, which is documented in the proof step for Q1, which is question 1. Now we will rush through the proof steps of the eProof environment just to perform a few steps step by step. Select the next proof step description. Select the connection to the previous proof step. Select the justification of the proof step. Seeing the previous assessment of the proof steps and submit. If the student repeats the workflow for all proof steps, then he will see the final assessment of the proof if it's switched on for the direct feedback on his proof. The direct feedback is recommended if it's used as a learning environment, so that the students will get direct feedback on their solutions. In the settings of the proof, you can switch off the direct assessment, and you can switch off the colorization of the proof steps. In the settings of the proof, the author can predefine how many options are available for the students. It means how many black options are there he could choose from. If you increase the number of black options, it's more difficult for the students to select the correct proof step at the current stage of the proof. If the proof step highlighting is switched on, a green option has the meaning that this option is applicable at the current stage of the proof. The green options are mainly used by authors for debugging the solution. The option up there is created automatically by the eProof environment, so that the authors can copy and paste the generated solution into the theorem definition. All proof steps following the same principles. Select the proof step, select the connection to the previous proof step. This is the connection to the previous proof step, and select the justifications of the proof step. This is the first proof of concept that eProof environments can be integrated in iMathAS or other learning environments for mathematical subjects. And thank you for watching.